One punching and shearing press, 4 workers, 0 safeguards. No interlock, no synchronized multi-button control, no light curtain, a sensor grid that stops the machine if you break the infrared beam. Just cost-cutting and overloaded operators. It's not a freak accident, it's designed failure.
The SawStop safety system works, and it has saved thousands of fingers. Here, in a few simple steps, let me walk you through how it works. When the saw is on, it's constantly on the lookout for change. Each SawStop saw has a brake cartridge just underneath the blade. And through the arbor, the saw introduces a small electrical signal onto the blade. When the woodworker touches the blade, their body absorbs that electrical signal. A digital signal processor in the brake cartridge detects the change and triggers the release of a heavy-duty spring, forcing an aluminum brake into the spinning blade. The saw blade goes from 4,000 RPM to 0 almost instantly. The blade's momentum forces it to retract below the table, and the motor is automatically shut off. All of that happens in less than 5 milliseconds, 10 times faster than a car's airbag. 10 times faster than your reflexes can respond to danger. Fast enough to turn a life-changing event into a minor cut. And all without damaging the saw. After activation...
All right, welcome back, everybody. This is Professor Lusheen. This is the summary or preview of video for Lecture 16, which is machine safeguarding, and we're going to cover subpart O of the General Industry Standards. Give me 1 second to get this set up. There we go. Again, we'll still be reusing the old video, but I just want to kind of give you some updated information regarding safeguarding. So, subpart O, machinery and machine safeguarding. Standards are basically 211 through 219. But in this case, you need to follow ANSI B11 standards. They are more specific, they're more current, and they provide actual specific things you need to do. A lot of machines you purchase brand new will have guarding up to the ANSI B11, and if it does, it would be labeled as such. But older machines or machines that have been modified in the workplace, you may have to design your own. So, just like before, it's kind of difficult to find just machinery related. So, NIOSH took a little bit of liberty here, talking about contact with objects and machinery. Yeah, they tend to be more machine related. I've got some older data here, which talks about machines, mobile versus stationary, so vehicular versus other machines. So it would fall under contact with object, but contact with object doesn't have to be a machine per se. Not too long ago, and we talked about this, that if you have a worker who experiences an amputation, you have to contact OSHA within 24 hours. And they're now posting their data and a breakdown of sort of the amputations or severe injuries. You see that 3 out of the top 5 were caught in machine, and pinched or compressed within a machine. And then here are the numbers. These are not death. This is injuries themselves. Most frequent injury is actually a near miss. More people stick their hands in and around machines when they shouldn't, and nothing happens. Next would probably be laceration, because there's usually like a minor cut. You saw in the videos I had provided, it's probably contusion, laceration. Third would be amputation. Then fourth would be death. As far as cost concerned from the Liberty Mutual, number 8 is caught in equipment. If you do an accident search by machine, you get a bunch of these. These are fatality, correct? Employee dies, sustains head trauma. No, they're not all death. Killed, dies, killed, struck by, dies, killed, injures eye, fatality, asphyxiation by death. So there's a lot of ways in which people can be severely injured, debilitating injury, or killed when working in and around machines. It's number 10 on the most frequently cited standards. This is the 1910 212. Oh, sorry, went too far. So then I did a profile. So 212, 13 million. I think that's the highest we've seen so far. I do. I think this is the highest we've seen so far. And it's basically in manufacturing. And then we've got woodworking machines. So this would be like table saws, drill presses, things like that. A million. And quite a few inspections and citations. Similarly for abrasive wheels, these are usually benchtop grinding wheels, maybe an oscillating wheel, something like that, 600,000. We got 475,000 for mechanical power press. Here's the thing, this used to be a much bigger issue, but now most power presses are hydraulic, and they tend to be either foot actuated, two-hand actuated. They have light curtains now, and so mechanical power presses are not as dangerous as they used to be, but companies still use the old ones with the flywheel. So you activate it, and then it goes through its cycle. But so some of those still require guarding. A lot of companies, what they'll do is they'll use distance and two-hand actuators to protect workers. Mechanical power transmission apparatus, 1.9 million there. Here is the OSHA machine guarding homepage, or safety and health topics page, and that's where you can see where the standards are. We had looked at that previously. Hazard recognition, possible solutions, and actions. Here's how you do the hazard recognition. It's just basically anytime a machine either cuts, presses, spins, or oscillates, you have to protect the worker from point of operation. That's really what it comes down to, is protecting from point of operation. And if you recall from the textbook, barrier analysis is probably the number one way you're going to evaluate. Secondarily would be failure modes in effect. When something may fail, how could a worker either disable or work around a guard? And just because they go around a guard doesn't mean they're going to get hurt. That's why I said near miss is number one. But you have to keep an eye on it. You can't just put a guard in place and say, hey, we're good. And make sure, like if it's an interlocking guard, that it's actually, they're not defeating it in some way, shape, or form. Interlocking guard is when they like open a gate or a door or something like that. That should deactivate the running of the machine, but sometimes what workers will do is they'll defeat that. And so they can open a door and it's still operating. So yeah, it's basically being systematic, breaking everything down. And, I do recommend bringing in experts. Here we've got the different types of safeguarding. There's usually stickers, do not remove guard. You have to put that on there. I like this auto, around, under, through, or over. That's kind of the basic principle of machine safeguarding. If a person can get, I think 1/2 inch is what the basic limitation is. But then there's also these measurement devices, and what it is, it's a distance. So the further away the guard is from the point of operation, the larger the opening can be, because a person can't stick their whole arm in, but maybe they can stick a finger in. And so that's a general principle, and you can get these probably for free. Compliance officers carry them around. I had one at one point in time. I don't know where it went. I don't do machine guarding all the time, but that's the basic principle. It's, the opening in order to feed the product, that whatever you're doing, whether you're cutting, grinding, bending, whatever, if it needs, the larger the opening, the further away the guard needs to be. And sometimes you have adjustable guards, things like that. So there's different things you can do. My go-to experts is Rockford Systems. I've had them used to have them come to campus, and they would do a lecture, and it was amazing. They now have a lot of videos. They provide training, like 8-hour training, 10-hour training, or something like that, down in Rockford. I consider them the experts. There are others too, but these are the ones I've learned to trust and go to, and it's the resources I've provided for this week. So real quick, before you get to the video, I'm going to show a few more things, but I really want you to understand it is important that guards, and you see they have them yellow. I think it's a good idea, so that they stand out, that you can see them. It's more difficult for workers to try to remove something or defeat a guard if it's yellow, because you can go around and see it. So that's kind of the principle, is to be able to have it more visible. So here's the machine guarding page. Want to check this out. Here's a link to an ANSI B11. I know about B11 because of Rockford Systems. Is there a way that we can see how much it costs nowadays? So $200. Here's a link to the severe injuries, and you can put in different criteria. I just wanted to point that out. A link to Rockford Systems. I really like their stuff, you guys. Let's see. They also do lockout tagout, it looks like. They used to have all kinds of videos, and I did provide a video link on our page. Yeah, and here it is. So there's an hour-long machine safety compliance back from 2017. So this is optional. You do not have to watch it. So not a lot of information here. So watch the lecture video. And I provided some resources. But for the most part, most machines are modern machines. Should be equipped with safeguards. If it's an older machine, I recommend bringing in an expert. Don't try to do it in-house. This is just something that it's a responsibility you really don't want, ladies and gentlemen. All right, thank you.